Hey there! Welcome to another video where we dive into interesting programming topics. Today, we're going to tackle a common problem that arises when working with C++ shared-ptr in the standard library. The problem at hand involves the usage of different memory orderings for incrementing and decrementing the reference count. Why does the standard library use relaxed ordering for incrementing the ref count, but _rel ordering for decrementing it? Let's delve into this puzzling behavior and understand the rationale behind it. In the solution provided, it's crucial to note that while the control block of std shared_ptr ensures thread-safe reference counting, the shared_ptr object itself is not inherently thread-safe. Therefore, when obtaining a new reference to a shared object, you're essentially working with a safe reference already. As a result, the relaxed nature of the ref count incrementation suffices without necessitating strict orderings. Moving on to the crucial aspect of decrementing the ref count in the destructor, the emphasis lies on ensuring the correct synchronization for object destruction. When a thread drops a shared_ptr that isn't the last reference, the focus is on making any modifications visible to subsequent threads. This is achieved through the use of memory_order_release. However, when the last reference is dropped, synchronizing with release decrements from other threads becomes imperative, leading to the use of memory_order_acquire for the final thread. By employing memory_order_ac_rel universally, synchronization is maintained across all operations. In summary, the utilization of relaxed ordering for ref count incrementation and ac_rel ordering for decrementing in shared_ptr operations ensures efficient and synchronized handling of shared objects. Understanding these memory orderings is key to robust concurrency management in C++. Thanks for tuning in. Remember to like, subscribe, and drop a comment below with your thoughts. Keep coding, stay curious, and see you next time.